we are going to talk about DSQI. This is a Design Structure Quality Index. So this the value will range from 0 to 1. Now what is this DSQI? This is about architectural design matrix. This is about design. This is about architecture. So this is a proper matrix which will give us a number. So using the concept which were similar in the IEEE Standard 982.1 2005, the United States Air Force System Command, they use this information obtained from the data and the architectural design in order to derive this DSQI, Design Structure Quality Index, which varies from 0 to 1. So how do we compute it? Before that, there are certain AF Design Structure Quality Index. There will be 7 of them. S1 is the total number of modules. S2 will be number of modules dependent upon correct data sources or produces data used. S3 will be modules which are dependent upon the prior processing. So S4 will be the total number of database items, and S5 will be the total number of unique database items. S6 will be the number of database segments, like the record. If you make a table, one table in a database, number of records and individual objects. S7 will be those number of modules with single entry and exit. So this S1 till S7 will give numbers, and then we will compute the DSQI. How do we compute it? Before that, we have to compute D1 to D6. What is this D1 to D6? So D1 is the program structure. How do you define it? As I said, D1 to D6. This D1 is if the architectural design was developed using certain distinct method. If you have applied, or the software or the program or the architectural design was made using certain special distinct method, like the data flow oriented design or the object oriented design, then D1 will be 1. Otherwise, we'll put D1 as 0. So this is a specific value. It can be 0 and 1. This is the D1. As I said, we have to go from D1 to D6. What is D2? 1 minus S2 by S1. I told you all S1 till S7 you have to give numbers. So 1 minus S2 by S1 is module independence. Then modules not dependent on prior processing. So D3 equals 1 minus S3 by S1. So basically probability it is going. It's all probability things. So S3 by S1. Then the database size S5 by S4. You compute it and then subtract it from 1. You get the database size. Then the database compartmentalization, modularization, D5. So S6 by S4 and subtract it from 1. Module entrance or exit characteristic. This is S7 by S1 compute, subtract it from 1. So D1 till D6, this is how we get. So we have to give numbers to S1 to S7. These D1 to D6 can be easily computed. And DSQI will be simply WD. I is the subscript. That is, you have to do W1 D1, W2 D2 like this. Now you'll ask, what is W? W is simply the weight given to all these D's. This is a relative weight. If you say that something is important, you say module interdependence is very important. So you'll give a weight. Database size is important, you will get a weight. If module entrance exit is not very important, you will get a lesser weight. So this sigma WI should be 1. Okay. Now this weight you have to be along, it should add to 1. If all these DIs are equal weighing, then you will get this WI will be 0.167. So the value of DSQI what you got will be compared to the past design. So if the DSQI value is lower than the average what you have got earlier, it indicates that you need to work on your review and design work.